What's really happening? Before explaining what happened in the demo, let's first consider the structure of a cotton fiber. This should put into perspective why scouring is important when preparing cotton for textile applications. Cotton fibers are special in many ways. Each individual fiber is a single, very long plant cell, and the part that we see and spin into yarns is the thick cell wall. The cotton fiber cell wall is made up of several different layers. At the inside is a flat, hollow core called the lumen. Around the lumen is the secondary wall. This is the main part of the fiber. The secondary wall is made up of many thin, diagonally wrapped layers of cellulose nanofibrils. Different layers wrap in different directions, making each cotton fiber very strong. Outside the secondary wall is the primary wall, made up of a mix of cellulose, pectins, and other molecules. This layer protects the inner ones from damage, but it is not cotton's strongest defense. The thin outermost layer is known as the cuticle. This is where natural waxes and oils reside. The cuticle makes unprocessed cotton naturally hydrophobic, or water repellent, and is the fiber's first defense against pests, the elements, and mold. The cuticle is anchored onto the primary wall by pectins, but it is difficult to add dyes or finishes to cotton without first removing this cuticle. Many common methods, however, can damage the cellulose molecules inside. In textiles, this removal process is commonly referred to as scouring, and it is a key processing step that must be completed before the cotton can be dyed in any way. In this demo, we focused on removing the cuticle. In traditional scouring, sodium hydroxide is used at high temperatures to break down the pectin and remove the cuticle from the fiber structure. While this method is effective, sodium hydroxide can also damage the primary and even the secondary cell walls, breaking apart the cellulose polymer chains and causing the fiber to become weak. In order to remove the cuticle layer without damaging the cellulose, pectinase enzyme is used. Pectinase enzyme works like an X-Acto knife that only cuts the pectin that is holding the cuticle layer together. This splits the cuticle into small pieces that can be washed away during the process. The more pectinase you have available in solution, and the more pectin it can reach, the more extensive your reaction will be. Because the enzyme is selective, it leaves the cellulose in the secondary wall and the primary wall undamaged. When the pectin is degraded and the cuticle fragments are released, the underlying hydrophilic cellulose is exposed, which makes it easy to wet and apply dyes and finishes to the fibers in cotton yarns and fabrics. Cynium red, shown on the left, is an inorganic dye that binds to pectin substances, staining them purple. Similar to enzymes, its selectivity allows it to only stain pectins while ignoring other polymers like cellulose. It is an excellent visual check to determine whether your scouring was effective or not. There is a clear color difference when comparing the control sample on the right to the enzyme-treated one on the left. The enzyme-treated sample still has a very light tint of purple, but this is most likely caused by pectin that is deep in the primary wall and was not accessible to the enzymes without fully degrading the primary wall as well. After enzymatic scouring, the cotton is easy to wet out and ready to be bleached or dyed.